In circle, we have seen what is tangent, okay? And I've explained you tangent, and one theorem also we have seen of the tangent, okay? So what is tangent? Tangent is a line that touches the circle. Tangent touches the circle only at a single point, okay? Now we have studied the theorem, okay? One theorem was there, okay, and both the theorem and the converse both are correct, okay, both are true, okay, that the tangent at any point of a circle is perpendicular to the radius through the point of contact, okay. So when you're drawing a tangent, if it is touching the circle, the point where it is touching the circle, it will be perpendicular to the radius, okay, and the vice versa is also true. Okay, so this was the theorem that we have studied. Now today we will see number of tangent, and on that theorem we have solved some sum also, and we have done the sheet also, assignment sheet also. Okay, today we will be doing the other half, that the number of tangent from a point on a circle. Okay. Now, how many tangents you can draw from a point, okay, to a circle? Okay. Now, point can be at three different positions, okay, when we are discussing a point. Like, for example, this is a circle. The point can be outside the circle, the point can be inside the circle, or the point can be on the circle. Okay, these are the three positions if we are talking about the point. Okay, now since three conditions are there, so three different. Now, first of all, if the point is on the circle, so how many tangents can you draw? Any idea?
Four.
How can you draw four tangents,
And
Shizan?
ma'am, it should not intersect each
This
other.
is a point. From single tangent is a line that touches
One, ma'am, one.
only touches the circle. Okay, that means only one tangent you can draw from a point on a circle. Okay, if the point is lying on the circle, you can draw a single tangent. Okay, understood? Now, if a point is outside the circle, if the point is outside the circle, then how many tangents you can draw? You can draw two tangents. Okay, one like this and one like this. Okay, so two tangents can be drawn. Okay, now the third case is when the point is inside the circle, inside anywhere on the circle. If the point is inside the circle, there is no tangent, because the line that is passing from this point, that will touch the circle at 2 points. Okay, that will touch the circle at 2 points, so that means it is not a tangent, because tangent touches the circle at only single point. Okay, understood? Now, in this case, when you touch this, you can see that the tangent are touching the circle here. Okay, so here it will be the radius. Okay, so this length of the tangent will be equal. Okay, from a single point, if you're drawing two tangents, okay, then it will be equal. Okay, the length of the tangent will be equal. Okay, now what is the length of the tangent? Okay, the topic comes, what is length of the tangent? Now, length of the tangent is, if you're drawing this tangent, okay, only one point you can separate. I'll rub it and draw it again. Okay, this is the point of contact. So any point lying outside the circle, okay, from where you are measuring, like here I am measuring from here. So any point are lying outside the circle on the tangent to the point of contact. This is called the length of tangent. This portion is called the length of tangent. Okay, understood? Any doubt? I've given the notes also here. Okay, the length of tangent, and I've also told you the the point is equal. Okay, two tangents are drawn from an external point, then they both length are equal. Okay, in this case, a single point you are drawing two tangents, then their length will be equal. Okay, we will see this as a theorem here. See, this is a theorem. What does the theorem says? This is the theorem. What does the theorem says? The length of tangent drawn from an external point to a circle are equal. Okay, now how can you prove that? This is the circle. Okay, these are the two tangents. Okay, this is point A. Now it should be the center actually. Sorry, I did wrong. Okay, I'm naming it same. What is this one? Now, if you see, we have to prove that. To prove, we are doing construction. In construction, you are joining OP and OQ. Okay,
Okay,
and
ma'am.
to prove that, you can see the starting. To prove construction and then proof, I will explain you. Okay. So we have to prove that what? That is AP is equal to AQ. Okay. Now, for if you go on proof,
Ma'am,
yes.
Ma'am, here PO will be equal to OQ because ma'am, it's eventually
Yes,
the radius of the
it is
circle.
the radius. We'll see in the proof. Okay. OP is equal to OQ because it is radius. Okay. But this we will do afterwards. Okay. First we'll see if you're taking two triangles. First of all, after construction, this OP will be perpendicular to AP. How? Because AP is a tangent, and a tangent to any point of the circle is perpendicular to the circle, perpendicular to the radius. This is the theorem first. Okay, in the first section only we have seen the theorem. That means angle APO in triangle. If you write here in triangle APO and in triangle AQO. Okay, we are saying about the congruency, so that if the two triangles are congruent, we can say by CPCT the sides are equal or angle is equal. Everybody know this? Yes. So OP is equal to OQ because they are the radius. Now angle APO is equal to angle AQO, okay, is equal to 90 degree. Okay, how? You know, from the theorem. Okay, now AO is common. Okay, so therefore from RHS, because AO is what? AO is the hypotenuse, and this one side is equal and 90 degrees. So from RHS rule. Okay, so triangle APO is congruent to triangle AQO from RHS congruency. Okay. Now, therefore, what therefore? Therefore, AP will be equal to AQ. AP is equal to AQ because the two triangles are
Ma'am, by CPCT,
congruent.
right?
Yes.
Ma'am, we'll write at the last by CPCT, ma'am, AP is equal to AQ, right?
Yes, AP is equal to AQ. Okay, because the two triangles are congruent. Okay, so the parts of the congruency will also be equal from CPCT, you know, from the triangle. Okay, so we
Okay,
have
ma'am.
proved that AP is equal to AQ. Understood here? Okay, now since these two triangles are equal, then you can tell that these two angles are also equal. Okay, that means the line OA, okay, the line OA bisects the angle. Okay, bisect the angle at the center. Okay, see here. Thus, the center of the circle lies on the bisector of the angle between the two tangents. Okay, understood? And these two angles are also equal here. Okay, because the two triangles are congruent. Any doubt here?
No, ma'am, no, ma'am, no doubt.
And see, you have second method also. This was the first method that I have explained you. You want to go with the second method, so let's see the second method also. In second method, what you can say, I'll tell you the second method also. Second method is also easy. You can write any of the proof. Okay. Now, if you see this, it is a right angle triangle. Okay. Yes, both the triangles are right angle triangle.
Yes, ma'am.
So you can apply Pythagoras theorem.
Yes, ma'am.
What does the Pythagoras theorem say? That AP
Hypotenuse is
square
equal to base square plus perpendicular.
AO square will be equal to AP square plus OP square. Yes, okay.
Yes, ma'am.
And we know that OP is equal to OQ radius. Yeah, radii
And
you
then
can write. So
substitute.
AO square will be equal to AP square plus OQ square. And we are finding AP, so we are going to take AP on one side. So AP square is equal to AO square minus OQ square. Yes, you can write it here 1. And then for the second one, if you see, then you can write AQ square is equal to AO square minus OQ square. Same steps. Okay. Then I have written directly. So this one second. So from first and second, you can say that AP square is equal to AQ square. Now, if you are removing square on both sides, so AP is equal to AQ. Okay, so this is also a method here. Understood? Ridhima, Shazan, any doubt?
Yes, ma'am, understood. Ma'am, I'll be back in 2 minutes only.
Okay, fine. Go. Come fast. Any doubt, Ridhima, here? And then from other above theorem, point is noted that since the triangles are congruent, so OA is the angle bisector of angle PAQ. Okay, the angle that we are making at center, the line OA is bisecting the line that is they're passing from the between of the two tangents, that is actually bisecting that angle. Okay. Now there's some important results related to tangent to a circle. Okay, let Shazan come. Till then we are discussing first point only. So what does the first point say? That if two circles touches internally or externally, okay, touches. It's not telling you concentric. Concentric means center is same, but only touching. If two circles are touching either from inside or from outside, then the point of contact where that circle is touching, actually that point of contact will lie on the straight line that is passing from the center of the circle. Okay, you can see both the figures. Okay, but this one is internally, both the circles are touching internally, and the point where it is touching, it is passing through the point of contact of the center of the circle. Okay, and here the circles are touching externally. Okay, this point also we have seen, okay, just now, that if two tangents are drawn to a circle from an external point, then they subtend equal angle at the center. That means PO is the angle bisector of AOB, okay, and they're equally inclined to the segment joining the center to that point. Means APO, this angle is equal to this angle. Okay. And in fact, the two triangles are congruent, then you know that congruency means all the three angles are same, all the three sides are same. Okay, a pair of tangent drawn to pair of tangent means if you're drawing a circle is there and you're drawing two tangents. Okay, so either you can draw two tangents like this, okay, totally opposite. Okay, green is one pair, yeah, this red is one pair, so they are what, parallel. They both tangents are parallel, they're not going to meet and ever. Okay, but there can be a case when you're drawing the tangents and the tangents are at an angle. So if you're drawing the tangent at an angle, if they're not meeting here, if you're going to extend here, they're not going to meet ever. But if you're going to extend in this opposite direction, it is going to meet somewhere. Okay, so either if when you are drawing two tangents a pair of tangent, then either they will be parallel or they will meet at some point. Okay, that only the second point is telling you. Okay, this one. Now, if you see the third point, if two tangents drawn to a circle are parallel to each other, then the line segment joining their point of contact. Yes, this in this only. When you are see when two tangents are parallel, then the point of contact means where they are meeting. This one. This is the point where the tangent is meeting to the circle. Then this point of contact, if you join both the point of contact between the two parallel tangents, then it is the diameter. Okay, and if it is not the diameter, it is going to meet somewhere. Okay, understood? Shazan, I was discussing about the important results related to tangent to a circle. The first one you can see here, if you are drawing two circles, okay, which are touching internally or externally. I'm not talking about the concentric circle, only to any two circles of any size. If they are touching each other, then the point of contact will lie on the straight line that will pass from the center of both the circle. Okay, the second point tells you that if you are drawing a pair of tangent to two points of the circle, then either the point they will be parallel or they will intersect each other outside the circle. Okay, either the pair of tangents will be parallel, or if they are drawing at some angle, it will going to join somewhere. And if they are parallel, then the point of contact, okay, if you draw a line between the point of contact of two parallel tangents, then it is going to be a diameter. Okay, and the fourth point, we have seen that if you are drawing two tangents from an external point, then these angles will be equal. That means a PO will be the angle bisector of AOB. Okay, these two angles will be equal and these two angles will also be equal. Understood? Now,
Yes, ma'am.
if you are drawing a quadrilateral that is circumscribing a circle, that means the circle is touching the boundary of all, the circle is completely inside the quadrilateral, then the opposite sides, see, you can see the center, the opposite sides of the quadrilateral means this side and this side, they are making the angle at the center, that will be a supplementary angle, means the sum of these two angles will be 180 degree. Okay, these two, similarly these two. Okay, opposite sides, the angle that the opposite sides of the quadrilateral are subtending at the center of the circle. Okay, they will be supplementary angles. Now you need to do the questions. Okay,
Okay.
tomorrow we'll do the assignment on this, and that will be the end of this chapter. Now let's see the question. Now, what does the question say in the given figure? First of all, I need to copy the figure also. Now let's see. In the given figure, XP, and XQ are the tangents. Now you can see XP and XQ are the tangents from X. Okay, so XP, this one, and XQ. These two are tangents. From X to the circle with center O. R is the point on the circle. Prove that XA. See, R जो है, R is a point on the circle. Okay. Prove that XA and RA is equal to XB plus BR. So what do you think? How can you do it? Think for two,
I
three.
will draw a bisector ma'am from between from radius to a point. Like first we'll do that. Ma'am, can we do like this? So- Acha, you know, this was only I was going to tell. Ma'am, can we directly take the triangle AXBR so that we can prove it?
See, wait. You just see this much part of the circle. ये है ना, ये
Hmm.
सब इतना पार्ट देखो, ये वाला एक्स्ट्रा पार्ट नहीं देखो अभी, ठीक है। ये वाला इतना पार्ट देखो, यहाँ पे ये ए है, यहाँ पे पी है, यहाँ पे आर है, यहाँ पे बी है, यहाँ पे क्यू है। तो ये दोनों भी तो टेंजेंट ही हो गया, ये दोनों भी तो टेंजेंट ही हो गया। पॉइंट ए से ये टेंजेंट ही तो हुआ,
Yes, ma'am.
ये एक्सटीरियर पॉइंट हो गया, उससे दोनों टेंजेंट हो गया। इसका मतलब ए पी इक्वल टू ए आर हो गया और आर बी इज इक्वल टू बी क्यू हो गया, हो गया।
Didn't understood, ma'am.
ओके,
I'm
ठीक है।
not understood, ma'am. Not understood at all.
और ये देखो तो क्या कहते हैं, ये पूरा भी तो टेंजेंट ही है। ये पी एक्स देखो, पी एक्स विल बी इक्वल टू क्यू एक्स, क्योंकि दोनों टेंजेंट है, ठीक है। और पी ए इक्वल टू ए आर,
QB.
पी इज इक्वल टू ए आर, वो भी टेंजेंट है। क्यू बी इज इक्वल टू बी आर, वो भी टेंजेंट है। और अगर तुम लिखोगे पी एक्स को तो तुम लिख सकते हो पी ए प्लस ए एक्स, और पी ए
Ma'am, excuse me, ma'am.
ए आर प्लस ए एक्स। हाँ,
Ma'am, how QB is equal to BR and how PA is equal to PR? नहीं सर।
ये वाला फिगर देखो,
मैम वही वाला देख।
समझ में आया आपको? पीए को मैंने ए आर कैसे लिखा, इक्वल टू रिदमा पीए।
ठीक है ठीक है मैम समझ।
शजान देखो, ये पीए, बस ये वाला पोर्शन अभी हटाओ। ये जो आगे का ना ए बी एक्स है, वो उतना अभी इमेजिन मत देखो, वो जो आगे का स्टॉप क्लिप है। अगर तुम बस ये पोर्शन देखो तो ये भी तो एक, ये भी है, ये क्या कहते हैं, ये जो देखोगे तो ये ए एक्सटीरियर पॉइंट हो गया, ए से भी तो पी और आर पे टच कर रहा है सिर्फ, तो वो
ओके ओके
टेंजेंट हो गया। और उसी तरह से आर बी और ये वाला भी तो टेंजेंट ही हुआ। और जब एक एक पॉइंट से दो टेंजेंट्स जा रहे होते हैं तो वो दोनों इक्वल होते हैं,
इक्वल। ओके
ठीक है।
अंडरस्टूड।
अंडरस्टूड ना? यहाँ पे देखो मैंने प्रॉपर विथ वो करके रखा है, तो समझ में आ गया ना? तो वो दोनों कैसे, अभी क्वेश्चन समझ में आया ना, दैट हाउ वी गोइंग टू इट।
यस मैम आप समझ गए।
अब इसको ब्रेक करके लिख लो। पी एक्स को तुम आप ऐसे लिख सकते हो, उसी तरह से क्यू एक्स को भी, क्यू एक्स को क्या लिख सकते हो, क्यू एक्स को लिख सकते हो एक्स बी प्लस बी क्यू, और बी क्यू को क्यों लिख सकते हो बी आर, हो गया प्रूफ, ठीक है। और क्योंकि पी एक्स और ये इक्वल है तो फ्रॉम फर्स्ट यू कैन राइट दैट ए आर प्लस ए एक्स इक्वल टू एक्स बी plus BR. Understood? You can note down from here.
Written down.
Then, Ridhima done? Now, prove that two concentric circle. Concentric circle means center will be same of both the circle. Okay. Prove that the two concentric circles, the chord of the larger circle का chord है, ठीक है। larger circle chord means a line that touches two opposite points on a circle. Okay. Chord of this larger circle which touches the smaller circle is bisected at the point of contact. So it is telling you where the chord of the circle is touching the smaller circle. Okay, at that point it is bisecting the point at the point of contact. Means AP you have to prove AP is equal to PB. Okay, understood? Now since AB is touching the circle at a point. Okay, that means AB is the tangent to the smaller circle. I'm explaining you and then I will show you the points here written. Okay, so AB is what? Is the tangent to the smaller circle. So tangent of a circle at the point of contact is perpendicular to the radius. Okay, so if you join OP, so angle OPB will be equal to 90 degree from first theorem. Okay, that we did in the last class. Okay. Now C1 is the bigger circle, C2 is the smaller circle. Now this is making 90 degree here. And the chord of the circle, if you see, OP is the radius. Yes, OP is the radius. And OP is radius for?
Ma'am, for smaller circle.
Yeah, OP is the radius for the smaller circle. And what you can say here? The chord of the circle is bisected by the perpendicular. Yes or no?
Yes ma'am, you can say that.
Okay, already you know
Ma'am, can you extend
perpendicular
that
to
dotted
AB.
line more?
See, OP is perpendicular to AB from the theorem. Okay, the theorem says that the tangent drawn at a point, the tangent to a circle at the point of contact is perpendicular to the radius. Okay, understood? Now OP will be OP is perpendicular to AB na, and AB is the chord to the bigger circle. Yes, so that means the chord of the circle is bisected by the point of contact. This one you see, this point. AB is the chord of the circle, and since OP is perpendicular to AB, that therefore OP is the bisector of the chord. Okay, that is, it is going to bisect the chord. Okay, because the perpendicular from the center bisects the chord. If you're drawing the perpendicular to the center, from the center to the chord, then it is going to bisect the chord. Okay, and since it is a AB is a tangent for the smaller circle, so we know that OP is perpendicular to AB, and AB is a chord. So if you are going to draw a perpendicular to the chord from the center, then it is going to bisect the chord. This was also the theorem. Okay, I think last year this theorem was there. Class 9. Class 9, this theorem must be there. Okay.
In
So
class 9, ma'am, circle was not there.
circle was there. Class 9.
Ma'am, but it didn't come, ma'am. It was not there. But triangles were there.
Circle. See, circle is there. So many lengthy topics are there in circle. Distance of the equation, angle subtended, cyclic quadrilateral. So many points were there in circle.
Okay, ma'am. I thought it was not.
Distance of a line from a point, equal chords and their distance. This was your class 9th only. Theorem C, equal chords of a circle are equidistant from the center. Then there was this theorem also, I think. This is a theorem, okay? The perpendicular from the center will bisect the chord. Okay, you can, if you want, you can take the screenshot or copy it. Okay, only main this statement was there, and you
Okay.
already know that AB is the tangent.
Ma'am, can we do this in another way?
Tell me.
So I did by joining O, B, and OA, just making a line.
And OA. Okay, you joined it.
We get two triangles, so we can prove
Okay, so you are
them.
proving the triangles are congruent.
Yeah,
Yes.
yeah, yeah.
You must be said, you must be written that OA is the radius and OB is the
Ah,
radius. So a
yes.
radius will be equal. OB is the common point, and this is the 90-degree. Yes. So from RHS you have proved it.
RHS, yeah.
You can do that also, and then you can say from CPCT AB is equal to BB. See, to do a question, they are proving or any question, there are many ways. Okay, so you can do that way also, and in fact, you can do this way also by mentioning the theorem. Okay, your way should be correct. Okay, it should be related, and sometime when you're doing questions, sometimes it is mentioned that this way you have to go or using this, so you have to take care of. Okay, otherwise, if it is not mentioned anything, you can do whichever way you like. Okay. Now this question, try this question, okay? Then I will tell you. O is the center of the circle of radius 5 centimeter. Okay, O जो है center है circle का. Okay, centimeter radius. T is a point such that OT is equal to 13 centimeter, and OT intersect the circle at E. इसमें figure mentioned होगा. नहीं, figure mentioned नहीं है. I think question में. नहीं.
The figure is there, ma'am. Over there.
Figure T is a point so that OT is equal to 13 centimeter. Intersects the tangent of the circle. Okay, so this is there in this. Okay, now this radius is given. Okay, radius is how much? 5 centimeter. Okay, and this hole is given 13. And if you're going to join this, okay, so you can join this also. Actually, this will be touching. Okay, now you need to do it. Okay, or let it be. I'll copy the diagram. That will be more proper. So how you are going to do? O is the center of the circle. Then find the length of AB. You have to find the length of AB.
Ma'am, we can again do it like that, which you taught before.
What?
Ma'am,
See,
we
you
can
can find out the value of PT.
yes,
Okay.
by
OP is given and OT is given, and
yeah.
this will be 90-degree.
Okay. Yes, ma'am, we can use Pythagoras theorem and find it.
Okay, and you see here OP and AE. OP and
Ma'am, PT will be 12, right? 12 Pythagorean triplet.
what?
Ma'am, PT will be 12 centimeter.
Yes, PT will be 12 centimeter.
So then,
So you have got
so
PT. Now, PT will be equal to AP and plus AT.
PT will be equal to AP plus AT.
PT, I'm saying PT will be equal to PA plus AT.
PT.
Yes or no?
Yes, ma'am, it is true.
Okay. And if you
Ma'am, will PT not be equal to T and another point on the this side? Ma'am, if it's radius, we can draw one more.
what you
Nothing, ma'am. I'll draw the diagram and I'll send you. Is it okay?
yeah, okay. This and this will also be equal. They both are also tangents. You can take it as x, okay, and then this you can take it as 12 minus x, okay. AB is a tangent. Now AB is a tangent, okay. AB is a tangent. So if you are taking there's a figure. AB is the tangent. So radius will be perpendicular, okay, perpendicular to AB. See, AB जो है वो भी तो tangent है.
Ma'am, I was telling you from before, ma'am, we can use the method which we used in the second sum.
This is 90 degree. This will
Yes,
also be 90 degree.
yes, ma'am.
So you apply Pythagoras theorem in the second one also. So AT square is equal to AE square plus ET square. Okay.
Yes, ma'am.
ET will be what? See, ये 5 centimeter.
Ma'am, where is he, ma'am? Acha, okay.
OE को माइनस कर दो OT में से तो 5 you will minus ना, so 5 if you minus तो
Ma'am, it is AE square or AT square?
AE, हाँ,
AE square plus.
AE तो x है, x स्क्वायर हो गया, और AT जो है वो 12 माइनस x का होल स्क्वायर हो गया, है कि नहीं?
हाँ मैम, हो गया मैम.
प्रतिमा, एनी डाउट?
ओ मैम.
इसको सॉल्व करोगे तो फिर आपको वैल्यू x की मिल जाएगी. जब x की वैल्यू मिल जाएगी तो x जो है दैट इज इक्वल टू PA and AE. So value of AE you have already got. So BE will also be same. So AB will be BE plus AB. Did you understood?
Yes, ma'am.
So if you are going to solve this, 144 plus x square minus wait.
Ma'am, it will be 144 plus x square minus 24x is equal to x square plus 64. Ma'am, if we subtract 64 and 144, we would probably get 7. And it will be 7 minus 24x is equal to 0. Ma'am,
What happened?
Acha, 80. Okay. So 20 plus 6. 3.34.
Got it?
Yes, ma'am.
Any doubt?
No, ma'am.
So you can do the last question of this exercise.
I will try. Ma'am, it's the last question on this chapter.
Yes, means in the notes I have kept it last. Tomorrow you will do assignment. You will find many more questions also, and then we can discuss the questions, and then this topic is over.
Okay, ma'am. Ma'am, triangles, when we will do?
After that, triangle will start. I think from tomorrow only we will start triangle.
And ma'am, test?
Which test?
Ma'am, test, ma'am, pending test. When we will take?
Test will be starting from now. After triangle, I will start with the test.
Okay, ma'am.
Tests are important. That will be your what you can say.
Revision sample paper.
Yes, it will be your complete revision.
Make it a bit tough, ma'am.
You'll have a whole paper also, no? See, only tough questions will not come, Shazan. Sometimes what happens, you go on tough, and sometimes we lose marks in the small, simple questions also. ABC is a right angle triangle with angle OB as 90 degree. Is equal to 3 centimeter. BC is 3 centimeter. AB is 4 centimeter. And if you are going to find out with the Pythagoras theorem, you'll get this as 5 centimeter. This is not given. You're going to find out. Okay. Now you need to find out the value of radius R. To find out radius R. Take these 3 triangles. Okay. One triangle, this one. Another triangle, this one you take. And one triangle, this one you take. So, okay. So in area of triangle A B O, okay, this is half. Base will be what? AB. Height will be R, perpendicular, that is OD. Perpendicular will be OD. Okay, so it will be half into AB value is what? 4 into OD will be R. Okay, so it will be 2R. Similarly, area of triangle BCO will be equal to half into 3 into R. Okay, ऐसा करो यहाँ पे 4/2 ही रहने दो, easy होगा आगे कैलकुलेशन के लिए. 3R upon 2. Okay. Now if you take the area of triangle ACO, half into 5 into R, that will be 5R by 2. Okay. Now area of the whole triangle, if you take the area of triangle ABC will be half, base will be BC and height will be AB. Okay, so which will be equal to 1 by 2 into 3 into 4. Okay, so it will be equal to 2 3 is 6. 6 is equal to 5R by 2 plus 3R by 2 plus 4R by 2. So if you are going to solve it, 6 is equal to 2, 7, 8, 9, 10, 11, 12, 12 R. So 6, 6, 2 is equal. R is equal to 1.
R1, ma'am.
Yes, R1. Any doubt?
No, ma'am.
Tomorrow we'll see the assignment also.
Okay, ma'am.
Mom, can you show the question?
Yeah, question with solution. Any doubt in circle till now? Go through it. If you have any doubt, we can discuss tomorrow in the assignment class. Okay?
Okay, ma'am.
Okay, then bye bye.